Once you have used your calculator for all these values, you'll find that square root 8 is actually the largest, all the way down to the cube root of negative 8, which is a negative number. So here, this was generally well done last year, but some students thought that 29% is bigger than 0.29 recurring. Now this 0.29 recurring is the same as 0.292929, so on and so forth, right? Whereas 29%, it can be written as a number, 29 over 100, which is 0.29. Now comparing these two, quite clearly, 0.29 recurring is bigger by 0.002929292929. Okay, so that's question 1, 1 mark. Please do your self-marking and your corrections. Next, write down all the irrational numbers. Irrational numbers, they cannot be expressed as a fraction where, okay, let me just put it down, rational. R-A-T-I-O-N-A-L. Hey. R-A-T-I-O-N-A-L. Rational numbers will be A over B, where A and B are integers. That means it will be a number, a whole number over another whole number. Those are rational numbers. So as long as you see things like pi, pi is confirmed irrational already. Okay, so this will be an irrational number. If you see a square root, take note, sometimes it is rational, sometimes it is irrational. For example, square root 8. Can I borrow your calculator? For example, square root of 8 gives us a bunch of numbers that continue forever, but they do not repeat. So this is irrational. Compared to, for example, square root 9. Oh, it is 3. This is rational. Okay, because 3 can be written as 3 over 1. So be very careful with the square roots. And I also remember telling you that every time you see dots on top of a number, any number, you see a dot, 0.0584 with a dot over here, this will be recurring. It continues forever, but there is a pattern. Therefore, it is recurring. Okay? Please do not include 0.29 recurring over here. So see, 0.29 is actually 29 over 99 when it is recurring. So again, 1 mark. Next, 5 over 12 as a recurring decimal, 0.416 with a dot on top of the 6. Okay, sometimes when you key it into your calculator, you may see this 0.4166666, many 6, then there's a 7 at the end. Is that your calculator? Does your calculator do that? With a 7 at the end? It is actually rounding off for you. Okay, you are supposed to recognize that it's not supposed to be a 7. It is supposed to be a 6 all the way, which means that we write it like this. Next, 5SF, this was generally well done. You have to include the 0.0. Next page. Okay, this was badly done last year. So we are supposed to subtract 9 times the product of x and 3h. Okay, let's break this down part by part. Product of x and 3h. This means x times 3h, which means 3xh. Okay, so far? Now it is 9 times this. 9 times this. 9 times of this, which gives us a total of 27xh. So this portion tells us it is 27xh. And we are supposed to subtract this from something else. Subtract this from what? From the quotient when k is divided by 2y. The second part, this refers to k over 2y. Okay, this is the quotient, k over 2y. We are supposed to subtract 27xh from this. Take away 27xh from k over 2y. So these are some of the common errors, don't know what they are doing. Next, subtract the sum. The sum of these two. We are going to add them up. Then we're going to take it away from this. So our first step will look like this. Our first step can look like this. 3x squared minus 1 plus 5x. Okay, now I am going to take away the sum of 5x squared minus 7x plus 4 plus 2x minus 5x cubed plus 1. I'm taking away the sum from this. So inside the bracket, we can simplify. Negative 5x cubed. Okay, I'll just continue at the bottom since there is not much space. 3x squared minus 1 plus 5x. I'm going to take away, inside the bracket, we've got negative 5x cubed. I'm going to start with all the bigger power first. Then I've got, x squared plus 5x squared. I'm going to work on the x terms. We've got minus 7x plus 2x. That gives us minus 5x. Then we've got 4 plus 1, which is 5. Okay? So now we don't have any more like terms inside. They're all different. X cubed, x squared, x, and a number. So the next line, I want to get rid of this bracket. Copy this down, 3x squared minus 1 plus 5x. When I remove the bracket, I have to be very careful. What is outside the bracket? It's a negative sign. When there is a negative sign, all of them they're all going to change. Okay? So now, this is negative 5x cubed. It becomes positive 5x cubed. What we are actually doing is negative. Okay, I'm going to draw in the invisible 1 over here. There is an invisible 1. We are actually taking this invisible negative 1 multiplied by negative 5x cubed. So negative, negative is positive. Which is why I'm always saying that we change the sign. Negative become positive. Negative times positive 5x squared. Negative and positive, we get negative. So we change the sign. Minus 5x squared. So instead of thinking, change sign, keep on expanding, it just simplifies to become, look, negative 5x, change the sign, plus 5x. Look, it is positive 5, change the sign, it becomes negative 5. And let's finish it off. You can do it any sequence you want. I like to start with the bigger power first. Okay, I like to start with the bigger power, so I have 5x cubed. Okay, there's only one x cubed term. Now let's look at the x squared terms. Okay, 3x squared minus 5x squared. We have negative 2x squared. We've got a 5x plus 5x. That's a plus 10x. Minus 1, minus 5, that's minus 6. Can I have a show of hands? How many of you got this correct? How many? Okay, how many of you got this wrong due to careless mistake? Okay, so please be very careful. Most likely it happened during the brackets. Next, estimate. Estimate this. Correct answer to one asset. Generally well done, except some of you went to calculate the exact value. You key this whole thing into your calculator, you get an answer, then you round off to one SF. That's not estimation. Okay, you are supposed to round off every single number first into something that is manageable. So 49.97 is roughly 50. So you look at this sign over here. This is the estimation. So 49.97 becomes 50. 4.1302 becomes roughly 4. cube root of 124.869. Now, you can either write 125 or they actually accepted 100. Why would they choose 125? That's where you need to be familiar with your cubic numbers, your perfect cubes. 1 power 3 is 1. 2 power 3 is 8. 3 power 3 is 27. 4 power 3, 64. 5 power 3 is 125. So when you cube root this, you get 5. When you cube root 64, you get 4. When you cube root 27, you get 3. So they are actually trying to get you to realize that 124.869 is very close to 125. And when you cube root that, you are actually dividing by 5. And that's how you get a value of 2000. Although they accepted this cube root of 100, personally I don't think it is very good, because if you cannot cube root 100 and get an integer. What happens when you cube root 100? Do it now. You get a weird number, right? In other words, 100 itself is not a perfect cube. 100, 2, 50, 2, 25, 5, and 5. 100 is the same as 2 power 2 times 5 power 2. Look at the powers of 2 and 5. What are they? 2 and 2. They are even numbers. They are multiples of 2. Therefore, 100 itself is a perfect square. But that is because the powers are even. They are multiples of 2. If I need it to be a perfect cube, then they have to be multiples of 3. 3, 6, 9, 12. Then they will be perfect cubes. Okay, next one. Here we have ratio, but this is in milliliter, this is in liter, this is in liter. Your job is either to change all of them to liters or change all of them to milliliters, and you will get this answer as the final answer. 15 to 12 to 8. 1 mark question. If your final answer includes the units, 0 marks are given. Okay, you cannot have the units in the final answer for ratio. No units. So this is actually 0 marks. Can I move on? Okay, book sale. Calculate the total amount she paid for 2 books. 1 book, $18, includes 7% GST. So if she buys 2, the second one is at 30% discount. So the total amount will be, this refers to 70%. Because if you get a 30% discount, we are actually paying 70% of the original price. 70% of $18 plus the first book, which is $18. We get a total of $30.60. This is the amount that she pays for those 2 books. Okay, now is GST in here already? Is GST already inside this 30.60? Yes, it is written. It is including 7% GST. So let's move on to the next question. Find the amount of the GST paid. So the GST is 7 units out of 107 units. Multiplied by 30.6. She is paying 30.60. We're going to divide this by this 30.6 by 107. Then we find out how much 7 units cost. Because 107% represents 30.60. We want 7% represents 30.6 over 107 times 7. Same working. And we get $2. What is the common mistake? The common mistake is 7 over 100. Is that you? Okay, just be honest with me. How many of you actually did this? 7 over 100. If you did 7 over 100 times 30.6, you will get a different value, and that is not correct. The difference is this denominator. If you divide by 100, you are saying to me that the GST was not inside 30.6. Okay? But the GST 7% is inside the 30.6. The 100% represents the original without GST. Okay, so when you add GST, it becomes 107%. Okay, so we're going to skip question 6 because inequalities, all these greater than, less than, they are not in our syllabus. But you have actually learned them in primary school, right? So you didn't learn all this? Did you all learn this in primary school? Okay. But yeah, I remember my primary school teacher showed me this 3 greater than 1. Different Then she go and draw the crocodile, the mouth, then eat the 3. Don't know what's happening over there. Never mind. Okay, next. Question 7. 3 cubic centimeters as a percentage of 0.06 cubic meters. So this is 0.05%. 0.005%. How do we do this? We need to make sure that they have the same units. If you want everything in cubic centimeters, then you must change it to cubic centimeters. And can all of you imagine what is the most common mistake? Then you times 100. And you get 6 cubic centimeters. Then this will be wrong already. This is the most common mistake. Okay? So how do we remember this? We remember it by, actually all of you are good at remembering. 1 meter equals to 100 cm. All can do this, confirm. But what about 1 square meter to cm square? Then you put a square here. Then what if it is 1 cubic meter to cubic centimeter? Put a 3 over here. Okay? Then this is the conversion. So for example, if I want 0.06 cubic meter will be 100 cube divided by 1 times 0.06. 100 power 3 over 1, 0.06. And we get 60,000 cubic centimeters. Okay, there are 2 lines of symmetry. Need me to show you where they are? 2 squares so that the rotational symmetry order 4. These are the 2 squares. Any other answers that you have? I don't think so. So in shade, you can shade like this. Next. Okay, this is, I admit this is a little difficult. But let's do a quick recap for this first. Find m such that 40m is perfect square. Okay, smallest, least. How will you do this question? Now first, we have to check. What is 40 equal to? 2 power 3 times 5. All of you can do this? So if I need 40m to be a perfect square, which is 2 power 3 times 5 times m. This is 40. If I need 40m to be a perfect square, that means all of this is also a perfect square. Now perfect squares, their powers have to be even. That's how we get a perfect square. Okay, so this 2 power 3. Is 3 a multiple of 2? No, it's not. What do you need it to become? Yeah, you need it to become 4 in order to be a multiple of 2, so that it will be a perfect square. What about this 5 over here? What is the power? Is it 0 or 1? 1. It has the power of 1. So what do I need that 1 to become in order for this to be a perfect square? I need this to become a 2. Okay? So our perfect square ends up looking like this. 2 power 4 times 5 power 2. Now this is a perfect square, right? Then comparing this, what is the value of m? 2 times 5, which is 10. Based on this. What if I say it is a perfect cube? What if I want it to be a perfect cube? So all these must be a perfect cube. So 40 is still 2 power 3 times 5 times m. If I want it to be a perfect cube, what would the new power of 2 be? Can it remain as 3 or must I change? Remain as 3. What about the power of 5? What should it become? Also 3. Now this is a perfect cube. And comparing them, what is the value of m? 5 times 5, which is 25. Okay, the variation to this question is divided by m. Perfect square. Okay, so now I'm going to put it as 40 over m. 2 power 3 times 5 over m. Now this is I want this to be a perfect square. So what will my power of 2 become? Currently it's 2 power 3. I want to divide by something so that my final 2 power something is even power. When you divide by a number, does the power increase or decrease? It will decrease because we are dividing. So our new power becomes 2. Then times 5. The current power is 1. 1 is also not a multiple of 2. So it also needs to drop down, right? Drop down to what? 0. 5 power 0 is 1. We don't bother writing down multiply by 1. So based on this, what is m equal to? 2 power 3 times 5 divided by m equals 2 power 2. So what's m? 10. Okay? This is the recap on how we should do this question. Coming back to this, our 40 has a value of 2 power 3 times 5. Then it is multiplied by m divided by n. I want all of this to be a perfect square. Meaning, powers of factors are multiples of 2. Can you please write this down? The powers of the factors. What are the factors? 2 and 5. The powers are multiples of 2. Okay, then now we look at it. Currently, 2 has a power of 3, 5 has a power of 1. We need to make either the 3 become 4 or become 2. We need to make the power of 5 become either 0 or 2, because those are multiples of 2. So we actually have 2 options. The first possibility is that we let m be equal to 2. If this m becomes 2 and becomes 5, we end up with 2 power 4 as the answer. Can you see that? And this is a perfect square. But how did they decide that m equals to 2, n equals to 5? What if it is the other way around? What if I say that m equals to 5, n equals to 2? Then I'll have 40m over n, 40 2 power 3 times 5 times 5 over 2. Right? If it is this case. I also get a perfect square. 2 power 2 times 5 power 2. See, all the powers are even. Can this be accepted? Why not? Can this be accepted? Why not? Why not? And so you all learned inequalities already lah. Because m is smaller than n. So this m is bigger than this. So this is not correct. Okay? Now, lesson is over already. Bring this home. Continue to work on it if you have not finished the paper. I'll continue with this next lesson.